5th International Conference on Intelligent, Sustainable, Social and Secure Computing. So, with the sub-themes like intelligent computing, sustainable computing, social computing, and secure computing. So today we are in the plenary session 2, in which we have eminent speakers from academic and industries who will throw light on our sub-themes like sustainability, social, secure, and intelligent computing. So I request all the participants to just listen very carefully what the esteemed and renowned plenary speaker is going to talk about these particular things. We have Dr. Preeti Khanna, Mr. Ankit Kothari, and Mr. Professor Hiren Joshi. They are well known and renowned personality in their field. So I wish that students and all the participants will go through carefully about their session and will ask certain queries and questions regarding this theme and sub-theme. So first of all, I would like to request Dr. Preeti Khanna, Professor Computer Science and Engineering, PDPM, Triple IT, DM Jabalpur, for delivering her plenary session. And then after that, Mr. Ankit Kothari and then Professor Hiren Joshi. Over to you, ma'am.
Thank you very much, sir. Yes, ma'am. So moving ahead, today we have 3 distinguished speakers with us to share their valuable thoughts. Our first speaker is Dr. Preeti Khanna, ma'am, Professor at PDPM, Indian Institute of Information Technology, Design and Manufacturing, Jabalpur. Here is a brief introduction about her. Madam's main area of interest include image processing and computer vision, biomedical engineering, biometrics, deep learning, and computer-aided product design. She is a recipient of the UGC Fellowship in India and the long-term JSPS Fellowship in Japan. She is a senior member of the IEEE Computer Society and has published more than 100 papers in reputed journals and conference proceedings. She also published a book and has working experience on many projects. She has organized various conferences and workshops. Presently, she is serving as associate editor of 4 journals and also served as a guest editor for renowned journals. On behalf of SVV fraternity, a warm welcome to you, ma'am. Ma'am is going to deliver her knowledge on the topic deepfakes. Audience is requested to type their queries in the question answer box. Maximum queries shall be answered as per the availability of time. Now may I request to Preeti ma'am to share her knowledge with us. Over to you, ma'am.
Thank you so much, madam. And I'm thankful to the organizers for inviting me in this forum for interaction and share some thoughts on deepfakes. So let me share my presentation. So is it visible?
Yes, ma'am.
Okay, thank you. So once again, thank you for inviting me, and I would like to present on deepfakes, which is a current. Many of us have been heard about it. So I thought this will be the topic which might be interesting to the participants, because a lot of interesting ideas are there for research in this direction. So I would like to tell you, I don't know how many of you are aware of my institute, that is Pandit Dwarka Prasad Mishra, Indian Institute of Information Technology, Design and Manufacturing, Jabalpur. We are, close to you. And this institute was established by Ministry of Education in 2005, and we have been declared as Institute of National Importance by Government of India under IIIT Act 2014. And we are having a very lush green campus. I would like to invite all the participants and organizers of course to visit our campus, because we are also organizing so many development program, workshops, conferences, online, offline modes. So, I mean, please visit us. So we are doing this in the three engineering streams, sorry, four now: mechanical engineering, computer science and engineering, electronics and communication engineering, as well as smart manufacturing, design, natural sciences, liberal arts. And we are having very state-of-the-art research labs and research-oriented programs, and that is how I'm inviting you to be here. And one of the striking uh, feature of our institute is collaboration with Japan. So there are two important things with our institute. One is, you must have noticed this long name, IT, design and manufacturing. So our institute came with a specific mandate, that is IT for design and manufacturing, as well as design and manufacturing of IT products. And another feature is this collaboration with Japan. So we were the first one here when the Japanese universities and in an industry, they make a consortium, and our curriculum, as you can see, we are coming up with a specific mandates of our curriculum and other activities. We got support from Japan professors and industrialists to visit our campus and offer the courses and help us in setting up these state-of-the-art labs. So these are some glimpses of my institute. So I've been this is computer library computer center from where CSE department operates. And I would take a minute to introduce you to my lab. So we are having this image and vision engineering lab under, I mean, some with I'm working with my colleagues, Professor Aprajita Ojha, Dr. Ayansh Ji, Dr. Durgesh. So we are working on so many applications of deep learning and in various areas, machine learning, deep learning. So this content-based image retrieval, then this gesture recognition, and lot of work is there on the biometrics. So we started with the palm print, then face, and we also worked on cancelable biometric, where, because we all are particularly careful about we are now careful about the security of the biometric. Then a lot of work is there on the medical image processing. So we worked on mammograms, we worked on this MR of brain MRIs, and then recently we are working on ophthalmological diseases. And apart from that, we worked on this precision agriculture, as well as this smoke and fire detection, because that is also a current problem. And apart from this, we did many research and consultancy projects, including a project we did for Alpha TKG Japan. And these are some glimpses of some of the works done in collaboration with my colleagues, as well as PhD and MTech students. Now, if I show you these pictures and I ask you, okay, can you believe that these are not real people? Because as a matter of fact, all these images are generated by a generative model. So I mean, you can see how difficult it is to imagine these are not. It seems like they are the people who are your next door might be. So now deep fake media, so it is image, video or audio files that are basically digitally altered, or you can say not sometime altered, they can be generated from the scratch using AI tools, so that we can impersonate real, or you can say non-existent people. So here you can see that StyleGAN, which is a famous model. These are the realistic images generated by the StyleGAN. And then you can see here, this is again a deep fake of Trump when he was declaring, okay, AIDS is over. So now you can imagine this has taken over, and it is very important for us to understand what is deep fake, and also understand how they are being generated, how we can counter I mean, how we can detect and take countermeasures against. So you must have come up, so because every coin is having two sides. So let us first talk about some, I mean, positives. So you must have come across certain videos on the YouTube. So for example, here, this first one is where we all are aware of Holocaust. So the students are interacting with the artificially rendered Holocaust survivors. Then another, Mona Lisa needs no introduction. So you can see here, this is a Samsung AI research lab in Moscow, which has successfully used AI technology to bring such personalities into it. It seems like, okay, you can bring Mona Lisa to life. And then we all, like my young friends, they are must be knowing more than me even, for this virtual avatar in the games where you can be there. And several more applications can be like this. But what has happened is, because now with the progress in the generative AI algorithms, now it is becomes very easy to create very realistic deepfake media, and this deepfake media can be used by scammers to spread misinformation on the social media platform. That is why we have to be very careful about the news which has been spread. And many times you must have came across, okay, some video you saw or some images, some speech, and it was a fake media. So now the fake media is, or you can say deep fakes, they are actually critical threat to the public trust and democracy, when because online exploitation is very much possible with it. And what has happened, if you go for the analysis of the fraud trends, then it indicates that the number of fraud cases are going to be increased 10 times in 2023 with respect to 2022. And about 70% of people, they are actually not able to distinguish between a real and a deepfake voice. I can say how many of us were able to say that those pictures were fake pictures. And here there are plenty of real life incidents where deepfakes are being misused. For example, this is an old example in 2022, when Ukrainian President Zelensky was portrayed that his troops to surrender to the Russians. So, and many, in fact, in this war, many fake videos came and to spread the information. There is another example I would like to quote here, that British engineering firm Arup, that fell victim to a deepfake scam, because attackers, what they did is that they impersonated as a company's CFO and other employees during a video conference. So the staff member, they was convinced that okay, he is the right person, and so he was deceived into authorizing 15 transactions for more than $25 million. So you can imagine, and so much. The financial things are implications are huge, in fact. So that is why most of the companies today, they are implementing their own developing their own system, implementing their own policies just to counter deepfakes. So here again, there are so many deepfake threats which are being shown here. Like we all know, like in the political, like the election is there, then some fake websites may be created with these deepfakes, and which can basically change the opinion of the people. Border control, spreading misinformation, like blackmailing, pornography, like so many threats are there which are supposed to be countered. So as I told you, okay, how to prevent it. So when a group of researchers, like a group of people are working on deepfake generation, then again a group of people or researchers are working towards developing deepfake detection techniques. So deepfake detectors, but what is the problem is that, suppose deepfake detectors you have trained on some media which is generated with certain AI tools, is going to be fail on the deepfakes which are being generated with a distinct different set of tools. So that is how we need to develop more powerful and robust deepfake detectors. And so if we talk about generation and detection, so most popular architecture for generation are GANs and diffusion models. I request madam to please let me know 2-3 minutes before that when the time is up, because we started at a different time. So just drop, let me know. So most popular architecture for generations are generative adversarial networks, and recently diffusion models. And when we go for detection, then of course this convolutional neural networks, transformers, hybrid architecture, all those are there. So when we talk about the procedure, how to create realistic deepfake, then basically we can do like certain we can alter certain aspect of a media file. For example, on your face, like some changes, some identity of some other person has been imposed, or the emotion of the speech may be altered. Let us say the content is same, speaker identity may be same, but how that thing is being presented, that might be different. And so it is and also not only that, you are changing something. As I told you, we can generate the content from the scratch very easily. So we are having these categories: domain agnostic and domain specific. So some techniques which are applied to all media types, or some techniques which are applied to a particular media type. So the first, I will tell you about deepfake types. So first is identity swapping. So here what we do is that we replace the identity information of a target person with that of a source person. And here we are preserving the identity agnostic attributes. For example, you can say the facial expression. Now here you can say in this picture, you can see this is your source identity and this is the target image. So here you can see that the this fake identity is created uh, by keeping these features. Features of the other source identity. So here, when we talk about this identity swapping in the visual domain, we call it face swapping. In audio domain, we call it voice swapping. And so when we talk about voice conversion, then here we need to change the timbre and prosody of a speaker with that of another speaker. And here we are preserving the content of the speech. Now, what happens? If we talk about speech, then this timbre and prosody, they are the key aspect of the speech that define how a speaker sounds and conveys meaning beyond just words. Because how we are presenting that information, everything is not being said. Something with that content can be interpreted. Okay, what do you want to say? So timbre is basically deals with the voice quality. Like it depends upon your vocal tract shape, resonance, harmonics. Like you can say, if you take example of a violin and a flute playing the same role at the same loudness, but they sound different, and because of their unique timbres. Similarly, prosody, that is rhythm, melody, and stress pattern in the speech that convey emotion, emphasis, and intent. For example, how I am presenting this information will be different if you are going to present the same information. So this is what we mean here. Now, next deepfake type is expression or emotion swapping. Here we alter the facial expression or emotions without changing the identity information. So that person remains same. So you can see that here only the expression, this is your target identity, and the face is not being changed, but the expression are being taken from the source. So here this is called facial expression swapping. And if we go for video domain, then we say is face reenactment or puppet master. So here what we are going to do is that we are altering the facial movements and which require facial motion capturing technology. And when we talk about audio domain, then it is related with changing the emotion of the speech while we are retaining the content and the speaker's identity here. So here we are not changing the identity, we are just changing the features. So another is facial attribute manipulation. Here you can see this changing certain semantics, right, while maintaining again the identity information. So here you can see some of the attributes we can alter, that is age, gender, skin color, hair color. So here you can see that in this example, facial hairs are being altered with. So then another type is talking face synthesis. So here this is, I mean, we can say that the most complex procedure, because here we are working on the procedure so that we can do deepfake audio as well as video content. And so generated content is actually conditioned on some target information in the form of like you can see text, audio, video, whatever, you can say multimodal content. So here you can see that target speech someone else, source identity is someone else, and then the fake video is being generated. Here you can see this. So here, if you see here, depending upon the speech content, the facial expression, head movement, lip movement are supposed to be synchronized, synthesized, and synchronized in this audio video content. And that is why we say that it is one of the most complex procedure. Then next is background swapping. Here we can see that we can generate we can change the background scene with a different one. So here you can see that the target background, I believe this is the Shibuya, which is a very famous place in Tokyo. So you can see here the source identity and just the background, fake background is being created. So you can say that, okay, I visited there. And if you say in the audio domain, then the background sound of the original recording is replaced with another background sound, of course, using audio editing technologies. And here we are preserving the speech content, speaker identity, everything. The background audio is going to be changed. Then next is text-to-speech synthesis. Here, the audio is can be created with, we know, all machine learning models. And by using those machine learning models, you can see here, they can be used for speech synthesis. And here some target text is there, some source voice is there. And so how I am going to speak this text, that can be created. So here these models are existing text-to-speech synthesis models. They produce natural speech and they can emulate the voice of a source identity. So the same text maybe with a different source voice. Then we have text to image or video generation. That is what you must be doing it. Daily we are getting these advertisement. You must be doing it with the AI tools and on DALE or there you are giving this text. Even Gemini, you must have seen the ad over there. Just give me this type of thing and they will create image for you. So this is a new type of deepfake. And after this diffusion models, and here we are saying that this text prompt. So here you can see that the text prompt is given, and based on the text prompt, the fake image has been generated. So here we can use images as well as videos, both. So here you need to, in fact, you can specify here. So here you can see that Morgan Freeman. So here you can specify the necessary details, the name of the source person. You can also give the facial attributes, body pose. You can tell it in the form of the text prompt, and the same has been included into the fake image. So it's similarly here in text-to-speech synthesis, the input text is pronounced by the system, while in text-to-image or video generation, the prompt is interpreted by the system as a set of instructions. Now, partial synthesis is also there. Here you are not playing with the entire file, but you are just changing part of an existing media file to create the deepfake. And so here you can just, for example, if you talk about audio domain, then you can change only a subset of words here. So not the entire speech. So you can see that this is target speech and this is partially fake speech, right? Not the complete. So, but here what is happening when you are doing this partial synthesis, then these changes are performed in such a manner that the target identity is maintained for the entire duration, not only for that part, not only for other parts, but for the entire duration of the video or audio clip. Then what generative models do, because here generative, earlier in the machine learning models or in the classification problems, we try to extract the features, we try to extract the important characteristics of this here. Here what we try to learn in the generative models, that is the data distribution. So here the aim is to capture the data distribution and synthesize new samples that share similar characteristics. For example, here it is being shown for the biometric data, these fingerprints, and this is the the source distribution. And if your model can learn this distribution from this data, then this is the estimated distribution of this data. This is the actual, this is the estimated, and then we can optimize it using a loss function. And when you are going to draw a sample from this estimated distribution, you'll say that quite similar to as it is drawn from the original distribution. So this is what we do. And so here you can see that once you have estimated this distribution of data, now you can sample, now you can generate new data. So here you can see that these are the new fingerprints which are generated using this estimated distribution of data. Now, if I show you this, just see this, how we can, we are talking about the attributes, facial attributes are being changed. So this is the video by NVIDIA, and you can see that how you can generate entirely new images that is going to give you appearance of the real pictures. So just have a look here. I will not, this video is available on YouTube. I just wish to show you for maybe for a few seconds. So here you can see that these are the source, like you can say a different this thing, and we can place it. And here this is source B. Now you can see that how this information is going to be imposed on this. So you can see that these faces are changing based on this source B. See? So these are some examples. So let us stop here. You can see this video on the YouTube. So now how deepfake generation is done. So there are two things. One is making use of autoencoder and decoder. So here you can see that these like encoder decoder architecture is there, where you can see this encoder, this learns the latent representation of you can see original face A and B, and decode using this latent representation of these images. This decoder is going to reconstruct these faces. So this encoder decoder pair is the same encoder decoder pair is going to be used to learn the latent feature of the faces during training. But what we do during testing, this here, okay, sorry, not testing, at the time of generation, the decoders are being swapped. How? Because such that you can see that latent face A is subjected to decoder B. So here you can see that, so decoder B, and then you can see here, this is the reconstructed face B from A. So you can see that this is going to be put it here. See the changes here. If you can see this, see the changes here, right? So how it is being done. So here there are so many applications available on net, where fake app, which are very popular due to their effectiveness in producing the realistic. This is called face swap based deepfake. Now another method, as I told you, GAN, this GAN, generative adversarial network, and this variational autoencoder, they are being used to generate again photorealistic images. So here you can see that this shows the progress. So it started in 2014, and I showed you that video, right? So 2019, and you can see that the quality of the synthetic faces as generated by variations on GANs are being improved. And 2020 onwards, diffusion model came into the picture, which are state of the art now, and they are more stable for training, and the sample quality is high. And so these are the images generated using diffusion models. So these are how we can generate deepfakes. And if we talk about a deepfake taxonomy, then so when the creation is there, then of course detection is there. But if we talk about early approaches, then they were focusing on detecting the what on the face. Let us say if you are finding out the spatial inconsistencies, for example, there is unnatural light, pixel level anomalies are there, compression artifacts. But these methods are fail when we talk about deepfake, because here these deep learning those methods are not going to be applicable here. Here we need to use deep learning models again. So if the deep learning is used to create deepfake, we are going to use the same AI technique for creating detection methods. So the deepfake models which are exploiting the data driven pattern, and they can learn to recognize these inconsistencies, right, which are not maybe not possible for us to identify. So here you can see that deepfake detection techniques, they are based on okay, some various categories: visual artifacts based, biological artifacts based, texture and spatial temporal consistency. So sorry. So basically, we need to find out the inconsistencies if we want to go for defect detection. So, so when you can say that the in the frames or in the picture, head poses, landmarks like on your facial, like whatever inconsistencies are there. So here, several sort of inconsistencies can be work out. Environment, like how the background works, lighting and other details. Forensic, then behavior, like how what some gestures are normal, some gestures or facial expressions are not that normal. Then if we talk about the videos, then the temporal consistency, so synchronization is there. Then physiology, like if you say the eye blinking pattern, or let us say heart rate. And then you can say, so these are the various ways, like, so the models, deep learning based models are developed so that they can identify the inconsistency based on these marks. So these are those who are interested in the research of the deepfake. They can see, okay, we are having several video data sets are available. So these data sets can be used for your research. And these are the very popular deepfake video data sets. Here you can see for face forensics, celeb this video forensics. So if you can go through the research papers, you will find that researchers have used these. And audio data sets are also available. If you are interested in deepfake audios, then these many data sets are there. You can have for your research. Then when we talk about deepfake tools, then there are several deepfake creation tools. For example, Deep Face Lab, Face Swap, Zao. And here you can see voice generation tools are also there. Resemble AI, my phone magic mic, voice my AI. So many are there. So I have just included it so that I'll share the slides. You can have a look over there. Then, as I told you, generation, those were the generation tools. Now we have the detection and prevention tool, Sensity AI, deepfake, deepware scanner, face forensic plus plus, right? So this is you can see, as I showed you in the previous slide, this is a research data set and tool set for deepfake detection. Then there are many AI generated image and animation tools are there. So I showed you that video that was from NVIDIA, StyleGAN, which is generating high quality faces. Then DALE, which is creating deepfake style images from the text prompt. You can just check. I mean, so many tools are there. So so many research and development tools are also there. And for example, Ganimator, this AI generated lips syncing, this wave to lip, which can enhance the lip sync accuracy in the deepfake videos. So those who are interested, they may follow that. And now that this discussion cannot be complete without talking about legal aspect. So right now there is a little law enforcement, despite these threats deepfakes are posing. And I believe that all across the world now the people have started talking about it, and they are coming forward to, so that the concerns may be addressed for the privacy, fraud, security. And then we can see that there are some global legal approaches for deepfake regulation. They have come up and coming also. So you can see in UK it is there, like European Union it is GDPR protections. In China, I mean, so if you say that till now the most well taken there in the China. Then in India also, you must have heard in the news, these IT Act and digital media guidelines are being coming up. So what we need is that, because we can't stop the technology, so we need to create a striking balance between the innovation and regulation, so that we can ensure responsible use of AI generated media, because that we cannot avoid. We have to go for it. So here I will just take a couple of minutes more. So this is, I have included just one example of the deepfake generation at our IV lab. So where basically, okay, what we thought is that, because much of our work was on biometric, and in the biometric, you know, that deep learning model, we require huge data. So we thought that why not we generate the realistic synthetic biometric for various modalities, including fingerprint, iris, palm print. And so we used a generative model, which was based on the convolutional autoencoder and GAN. And I'm not going into the detail of the model. You can find that in this paper. And I would like to show you the samples. So here you can see that these are the reconstructed fingerprint samples. Here you can see these are the reconstructed iris. You can match the quality with these are the test samples, and these are the reconstructed samples, iris. Then this is for palm print. And now here, so just to summarize, these are all artificial samples which are generated by our GAN, which we named as DSB GAN. And if you just so we compared it with the state-of-the-art GAN models at that time, because I mean this paper is becoming 2 years old. So DC GAN, B GAN, W, these are all famous GAN models. So if you can just compare the quality of the pictures produced in case of, say here, fingerprint, iris, and palm print, right? So that is what we did. Some detection methods also, they are not yet published. So some work is going on. And then if you talk about the deepfake research, future directions, then remember, we want detectors which can be generalized across multiple generative tools, because I told you what is the problem. If I have developed a detector that is working for the deepfake which are generated using a particular AI technique. But if there is a deepfake created by other technique, this method is going to fail, right? Then we need explainability. Explainability is the thing which are widely talked about these days in the artificial intelligence or deep learning based models. So we need to develop explainable deepfake detectors. So and not only deepfake creation or detection, but after detection, if we can sanitize it, right? So that is also another area. And remember, the current detectors, they are actually mostly relying on the deep neural networks. And so their uncertainty, right, that is it is difficult to quantify that, and therefore we want approaches so that we can calibrate deepfake detector. And if we can do this, then uh, we can take care of these deepfake generation. So generation, detection, right? This is a like you can say the war is going on. And so if we talk about deepfakes, what are the points to be taken away from here? Like we need to understand how deepfake is different from, because the beginning Photoshop or face swap, how it is different. Uh, why deepfake matters, believability, why it matters, because accessibility, it is accessible. And so it is, we need to explore more how these deepfakes are working. So these are the differences. You can go through it. And so this is all from my side. And if I'm sorry if I have taken more time, I believe. Okay. So any
questions? Okay. Thank you very much, ma'am.
So thank you so much.
Thanks a lot, ma'am, for your wisdom words. And we came to know so many things about the deepfake technology. Our next speaker is Mr. Ankit Kothari, Technical Architect, Cloud and Big Data Specialist. Here is a brief introduction about him. Ankit Kothari sir is technical architect with over 15 years of experience in building scalable cloud-based data platforms. He specializes in big data, Apache, Spark, and Databricks with a strong focus on intelligent and secure data solutions. He actively works on applying AI and cloud technologies to real-world enterprise problems. A warm welcome to you, sir. Sir is going to deliver his knowledge on the topic designing intelligent, secure, and sustainable cloud-based data platforms. Now, may I request to Sir to share his knowledge with us? Over to you, Sir.
Thank you, ma'am. And once again, thank you to all the organizers for giving me this opportunity to present here. Let me just share my screen. Is my screen visible?
Yes, sir.
Okay. So today I'll talk like how the modern system uses the cloud and the AI to build this intelligent and the data secure data platforms. This topic basically directly connects to what you see every day in the apps like Netflix, Amazon, Google, and also opens up the exciting career opportunities for the students here. So in the next 30 minutes, probably I'll be talking about what an intelligent data platform really means, why the cloud computing is the backbone of such systems, how the AI brings the intelligence here, why security cannot be ignored, and finally as a students of the Vaishnav Institute can prepare for the career in this domain. Uh, so feel free to note down your all your questions. Probably I'll be able to answer at the end. So what basically an intelligent data platform is? So an intelligent data platform is a system that collects the data, process that data at the scale, and produces the insights of it. For example, like Netflix just doesn't store your movies; it learn your preferences and the recommended content. So intelligence basically is coming from like data processing and learning, not the magic. So it's all data processing here. Oh, sorry, 1 minute. I think my system got hanged. So why basically cloud computing? So before the cloud came in, the companies has to buy the server and manage them physically. But with cloud, you will get the scalability. For example, today you might be having 10 users, but you can scale it to 10 million users. The second point is like the cost efficiency. So you pay only for what you use. The third thing is the global access. The users anywhere in the world can access it, and cloud makes the innovation like faster and the cheaper. So especially for the startups, it's very easy for startups, to innovate faster. Now, next thing is like the role of the AI in the data platforms. So AI helps the platform becoming this data platform becoming intelligent. Like for example, predictions. So predictions like the weather or the stock trends. Recommendation like every day we do shopping on the e-commerce sites. So we go for the shopping suggestions. We get those shopping suggestions. Automations such as chatbots and the fraud detections in the banking. And then today, like Gen AI tools like Chat GPT that are also like built on this cloud-based AI platforms. The next big thing, the generative AI in the modern data platforms. So how probably this generative AI is different from the traditional AI, right? Because it's basically generating the content for you. So it's not normal learning from the data. It's generating a content, and how this content is getting generated. Because this models are generated on a large data scale. Again, even for this Gen AI systems, right? The cloud is like the backbone of all this Gen AI systems. And again, we have to keep measure of the security and be responsible with all this AI concerns. So how a typical this data solutions or this data architectural systems looks like? You have like data sources. This data comes from different apps, click streams, sensors, users. So data is like generating everywhere, every minute, every seconds. Uh, then this basically, data gets moved to a cloud storage. Uh, Different, cloud providers are available today, like AWS, Azure, GCP. So once that data is available on this cloud storage, we basically process this data, the massive data. If you heard about Spark, right? A very popular framework for processing all this big data. Once this data is processed, we give it to the AI models, and then this AI models basically produces the analytics. So you think of this as a data pipeline where your data is flowing from one step to the another. Now we all know, right? From where does this intelligence is coming from? So there are multiple sources. One, you have a typical machine learning models where basically these models are trained on the past data, and based on the past data, it's giving you the results. Sometimes this intelligence can be the real-time analytics as well that reacts instantly, and sometimes we have a feedback loops where the systems like keep on improving as the data comes in. So for example, Google Maps, right, that keeps on improving the traffic predictions as more and more users travel on that same track. So now, why security is critical here? Because data is very valuable. Like it could be personal data, financial data, business data, uh, and any data breach, right, can lead to loss of money, legal issues, loss of trust. So that's why like security is like not an optional thing in the system. It is like mandatory in any intelligent data processing platform. So security by design. So means security like should be when you're designing any system, right? It should be built from the start. Like it is not a feature that can be added later. So this basically includes like identity and the access control. So where you're controlling who can access your data, who cannot, and who can, and how much control the person has on that data. Uh, encrypting that data so that it cannot be read by the attackers. So the encryption can happen at multiple places. For example, if the data is stored on somewhere like on a cloud system, it has to be in the encrypted form, which is called security at or the encryption at rest. And while also like when it is traveling across the network, then it has to be encrypted through SSL mechanisms, so that the attackers cannot listen it during the data travel. For that, your APIs must be secure. So one popular aspect is using the SSL and the TLS framework for securing their data. And of course, it should be a proper governance and monitoring system should be in place. So basically, secure system basically earn the user trust. The next thing is the sustainability in the cloud platforms. So sustainability basically here means is how how you're using your resources efficiently. So cloud platforms helps us in auto scaling. So using resources only when needed. So you don't need to provision your cluster upfront with a huge cluster upfront. You can only you can auto scale it as per your demand. So as per your users are growing, your traffic is growing, you can auto scale them. The second thing is the serverless computing. So in serverless, this your server only runs basically when the request comes in. So there's no idle server running, and it's just costing you for no reason. And then you have the optimized storage. So this basically reduces your cost and the energy consumption. Basically, it's good for the business and the environment. Challenges basically in managing this cloud data platforms. First is managing the large scale and the diverse data. So this data comes at a huge scale and the diversity. Like it can be from the multiple sources where they are in the different formats and all. So managing the formats, and then you basically have to ensure the data quality and the reliability. So like we know with the AI systems, right? You do a garbage in and garbage out. So ensuring like data quality and reliability is very important in building such systems. Security, privacy, and compliance. I mean, I think I already spoke on this uh, for the security part. The next thing is like the cost control and the resource optimization. So controlling the cost, like because you might be processing this large data because data is generating every millisecond. So processing this data every day. So controlling the cost of your solution is become increasingly important. And the final thing is when if in case you're integrating any AI or maybe a Gen AI solution in your this cloud data platform, you have to be very responsible in integrating such systems. Industry use case. This technology, probably the platform I'm talking about, is probably used in everywhere, like in the healthcare, banking. For example, in healthcare, you can see like in the disease predictions or the diagnostic. In the banking, it could be like fraud detection or the risk analysis. E-commerce, like every day we use we get the personalized shopping experience. In smart cities, like traffic and the energy management. So probably this cloud plus AI, right, like is transforming every industry as of today. Career opportunities for students. I mean, you can pick up any role today. Like for example, data engineering is the one role where you're using any data engineering framework to process the data and designing all the data pipelines. Cloud engineering is one where you're basically provisioning the cloud resources to manage or process this large data. AI engineering is again like it's always an evolving field. Like earlier we used to have machine learning engineers and neural network engineers. Now this field is again getting expanded to the Gen AI field and the agentic AI field. So Gen AI in the agentic AI is a world where you have a set of agents working in collaborations uh, and basically controlling complete data engineering workflow for you, where basically a large LLM is provisioned behind the scene, and that LLM basically with those agents are basically taking help from that LLM to process your solution. Another important thing, like we talk about security, right? No solution can work in today's world without the security. So being a security engineer or an architect is also a very good opportunity in this area. So some of the skills to start with, Python probably is getting popular day by day in all these areas, like especially in the data analytics, data engineering, everywhere. You can start with the cloud basics. You don't need to learn all the cloud environment, like all like Azure, AWS, GCP. I mean, just pick probably one cloud, and then you can start learning one cloud and skills around it. And then the data concepts and maybe the big data concepts, how to process this data. So Spark, as I mentioned earlier, right? Spark is one of the very popular framework. And on top of it, we have like Databricks. So Databricks is again very popular. It's basically a enterprise level solutioning for data processing, where you get a complete lakehouse solutioning for basically processing your data. You're getting the ML or the machine learning environment for processing the same data. So basically, it's a very hot industry topic as of today for the big data domain. So key takeaways. The basically to summarize, basically for building this cloud, this data engineering platforms, the clouds basically provides the stability. AI adds value and the intelligence. Security, basically is ensuring the trust on the system, and of course the sustainability, like to reduce the cost and the impact. Uh, Basically together they form the this our modern intelligent, what you call, data platforms. Okay, I think that's it from my end. If anyone has any questions, I can take it up.
Sir, I have a query. Am I audible?
Yes, ma'am.
These cloud data platforms are free of cost or it is payable?
This cloud, sorry, what?
Uh, the tools that we will use for the cloud data platforms are free of cost or it is payable?
No. For example, Databricks, right? It comes up with a community edition. So with limited amount of features, you can try it on your for free.
Okay.
But
Okay,
if you
thank
want to, but if you want to, explore more on this, some of the features might require an licensing and cost base. But to start with, it's all free.
Okay, so it is pay as you go, I think.
Yeah, I mean, different platforms comes up with different pricing models. So for Databricks, probably you need to check on the enterprise edition.
Okay, thank you.
Okay, thank you very much, sir, for enriching our knowledge. Our next speaker is Dr. Hiren D. Joshi, Professor and Head Department of Computer Science, Gujarat University, Ahmedabad. Here is a brief introduction about Dr. Hiren Joshi. Sir has versatile academic and administrative experience and is dynamically involved in almost all the important committees of the university. Dr. Joshi has 40 plus research papers and 5 book chapters in his account. He is actively involved in supervising PhD, MTech, and MPhil students, and also BOS member of different universities. Dr. Joshi has been invited as a resource person at many universities to take special lectures and as a guest speaker many times. Sir has also developed e-content for PG and UG students and contributed many training programs, coordinated many training programs. A warm welcome to you, sir. Sir is going to deliver his knowledge on the topic Beyond Algorithms, AI, Green Tech, and Trust in Society 5.0. Now, may I request to sir to share his knowledge with us? Over to you, sir.
Thank you, madam, and thank you, the family of SVV Indoor. I hope, am I audible?
Yes, sir.
Okay, so let me share my PPT, and the two speaker really speak very well about the theme of the conference. Is my PPT visible?
Not yet. Yes, sir, now visible.
I think I should. So the topic is related with the conference Beyond Algorithms, the convergence of AI, green tech, and trust to building society 5.0. So if we look at the thing that there is a poly crisis and there are challenges are converging. The challenges are like climate crisis, because we know that we all are using AI. But AI data center consumes 50% of global electricity and 650 million tons of CO2 annually. Then second challenge is trust deficit. 73% of user question AI transparency, and cyber attacks increase 15% annually. And the third concern or challenge is algorithm bias. AI algorithm replicate societal inequities and digital divide is widening. So we can think that we can no longer treat smart, green, and secure as separate vertical. They must converge. So what are the four pillars of convergence? So these are the four pillars of convergence. The first one is intelligent. So by using automation to autonomy. Sustainable means net zero compute. Of course, it's a bit difficult, but gradually we can go about that. Social is digital inclusion and ethics. And insecure, we have to design with privacy keeping our mind. If we take the dimension first, intelligent computing, so this is the main engine of that. And from cloud-centric AI to edge intelligence, earlier Dr. Khanna madam and Ankit Kothari sir has rightly said about that use of cloud and that. So cloud AI is a centralized processing, high latency and massive data transfer. While edge AI processing data were created, reduced latency by 95% and bandwidth by 60%. If we take real world example, then AI powered early warning systems for floods, earthquakes. So local processing will work faster alerts and lives can be saved. It matters because it enables intelligent system in remote and resource constrained regions. Dimension 2 is sustainable computing. So we have to think about green algorithms and hardware. The problem is that training ChatGPT-4, 100 plus million gigawatt electricity is used and 650 tons of CO2 will be come from that. The solution is that we should compress the model. We can use edge processing, use renewable power and carbon hour scheduling. And through that, we can achieve 80% of performance with 10 to 8% using energy. Third dimension is social computing. So society 5.0 is a human-centric design. And we know that Japan has a vision. They have started in 2016. AI solves societal problems like Japan has its own problem like aging population, healthcare accesses, and agriculture efficiency. And as the digital divide is wider, so that should be bridge the digital divide. So voice first interface for non-rated population, and it is very critical for in context of India. Real example is AI chatbots in local language improving agriculture productivity for rural farmers. And technology serves humanity, not the reverse should be happen. This is the core principle. Secure computing. So AI for security. So that means it should detect anomalies, threat hunting, and predictive defense. And security for AI means defending against adversarial attacks and model poison. So federated learning is very important here, which train AI without meaning users' private data by providing privacy preserving. And blockchain technology can be integrated. So that will be make audit trail immutable for supply chain and government transparency. So these are the 4 dimension. If this is the crisis, then that may be the 4 pillars for convergence. Now, if I move ahead, so I can say that the sweet spot is federated learning you can consider, where distributed AI training across networks, so that will provide you intelligence, privacy preserved through no centralized data exposure, so it makes secure. If you require less data transfer, so you need 40 to 60% less energy, so that will be sustainable. And equitable access to AI development globally, which is social. And the city indoor is, I can say, right example and the right place to do that, because we know that Indore is considered as a smart city, and Swachh Bharat Sarvekshan, I think continuously last 6 years or 7 years. Last year also, I think Indore get. So 6-year cleanest city champion from 2017 to 2030, right? And if we look at Indore's journey, so why Indore has do that? So the first one is that it has a smart traffic signals, right? And we know that this traffic signal as Indore has AI-driven traffic management and reduction congestion by providing AI cameras, and there is a penalty if anyone come through wrong side, and the cameras detect that number of vehicles, and based on that, the traffic timing for green light is dynamic. Sustainable means lower fuel emission and waste segregation automation. So again, Indore has a do all this. There is a better quality of life and public health improvements in that, and it has also IoT grade security. And Indore has a integrated with cities integrated command and control center ICC with integrated traffic management system, and AI cameras installed on corridors like BRTS, where system automatically detect and challan violations such as signal jumping or lane driving or overspeeding can be done. Then in waste management, it will be large-scale bio-CNG plant, and that will be compost and making its leader in sustainable solution under Swachh Bharat mission. And there is a concept called Govardhan initiative in Indore, and it facility process 550 tons of organic waste daily, which producing 70,000 kg of bio-CNG and 100 tons of compost, reducing pollution. It is a very good scale. It is India's largest municipal corporation solid waste based bio-CNG plant, and it converts wet and organic waste into bio-CNG organic nature. It utilizes a public-private partnership, means triple P model with Indore Municipal Corporation and private partners, and it generates clean fuel for city buses, cuts air pollution, promotes a circular economy, and earns carbon credits. and it is very good success ratio in that. Then third is water body revival is also by Indore. So Indore has that water body resolution, and I think I need to share my screen. Yes. So this is the compressive water management, right? And is it visible? Yeah, I think is it visible. So this is the effective segregation of wet and dry waste at the source. Swachh Bharat Mission initiative, strong implementation of government campaigns and local drivers, resource recovery because it converting wastewater into energy through large-scale bio-CNG plants. That's how I explained. And water body revival is efforts to clean and revive bodies. So that is we know that river can be used for mainly Kanha and Saraswati rivers, which heavily polluted with sewage. So Indore Municipal Corporation installed decentralized sewage treatment plants, STP, to treat wastewater before enter the rivers. And then pond and lake restoration, which includes like Pipliana Lake, Anpurna Lake, Shivpuri wetland at Ramsar side, and Vilakwali Lake. Then traditional water sources. So IMCS provide conservative and revival of 25 step wells and 455 wells. Catchment area management is also done very well, and public participation and campaign like the Jal Ganga Samvardhan Abhiyan, which campaign does, and for that it gave the Water Plus certified city in 2021 under Swachh Suraksha mission for its excellence in water and waste management. And it also gets star rating and Water Plus city. So it becomes the first city in India to receive this certification for its excellent sewage treatment and reuse. Star rating that it has secured high rating, including a 7-star city of garbage-free status, which is a major factor in overall Swachh Suraksha success. It is the cleanest city in the, as I already told, last many years, and 2024-25 also achieved. So these are the, and also Indore has a secured IoT grid. It is a smart metering infrastructure with Madhya Pradesh Western Regional Power Distribution. This system uses Synode secure IPv6 based Omni-based IoT. Then it has a design with in mind employing AI and machine learning tools developed by IIT Indore. And this tool monitor data in real time, anticipate threats, and detect unusual users patterns. Then there is a, you can say, SCADA integration, supervisory control and data acquisition solution with inbuilt feeder remote terminal utilities, and data-driven governance by Indore Smart City Development Limited. And Indore is actively involved in research on the security of this system, including the development of sophisticated models and framework like blockchain-based secure system for next generation cyber physical systems. So these all are the initiatives which help Indore very well. If we take second case study, then it is a precision agriculture, and for Indian context, it is empowering 270 million plus rural farmers through convergence. If we use IoT soil sensor plus machine learning predict optional planting trees and water needs, it is sustainable because 30% reduction in water uses and precision fertilization reduce runoff. Mobile apps in Indian languages can make it socialize, and small holding farmers can give competitive advantage. Blockchain verified land records, which is make secure and protect from fraudulent land restriction. So the impact is water will be 30% less, yield will be 25% more, and farmer income can be increased up to 40%. If we take third case study of trustworthy healthcare AI, and many states in India, especially for precision agriculture, not exactly precision, but in northern part like UP, Punjab, and Haryana, and some southern part has started that, especially for water leveling and other things. So the water can be used less. In healthcare, it's like balancing innovation and patient safety. So 50% diagnostic accuracy can improve, and 24/7 AI availability in remote clinics. And the protection is doctors can retain final diagnosis authority, explainable decision, transparent uncertainty flagging, and patient understand AI result. So result is that it enhance trust, plus improve outcomes, plus equitable across the quality care. Of course, there are a lot of work need to do in that, but still it is good. Then UN SDG target is required because UN has measured that AI green tech convergence is up to 40 to 60% energy reduction via edge computing. So here cloud computing make a big role. 15 to 25% city carbon footprint decrease, and there are total 134 plus UN SDG target accelerated. Each one is different, but these are, I discussed some of them, convergence model. The first one is Japan cabinet defines 7 principles of human-centric AI and AI-ready society roadmap for 2030. So in Japan, they started very early, but the main principle, it should be human-centric. So AI must not infringe on fundamental human rights and should expand human abilities rather than control them. And then education or literacy, ensuring basic AI education and skill for all to prevent a digital divide and social exclusion. Privacy must be protected. It guarantees that individuals are not disadvantaged by the use of their personal data. Security is ensuring by balancing AI benefit with its risk to enhance overall social safety. Fair competition, providing a fair environment for continuous AI development. Fairness, accounting, and transparency by ensuring decision making is trustable and results are explainable. And innovation is the 7th step, that fostering domestic and international collaboration to advance AI technology effectively. Then second one is European Union AI Act. So European Union AI Act was in force from August 1st, 2024. It is the world's first legal framework for regular AI, and it employs a risk-based approach, and they make risk categories: unacceptable risk means prohibited, high risk, limited risk, and minimum risk. Limited risk is including, like, for example, user must be informed they are interacting with chatbot or viewing AI generated deepfakes. And that can be general purpose AI, GPAI, you can say. This is standard and systemic risk. And they have timeline from 2025 to 2027. That from February to 2025, that bans on unacceptable risk practice take effective, and mandatory AI literacy training for staff begins. And August 2025, they make rules for GPAI model become applicable. And this GPAI systematic risk has a model which trained with high computational power, like 2 raised to 25 flops, which face additional burdens, including rigorous risk assessment and cyber security protection. And till August 2027, they want full compliance, high risk AI embedded regularized products, for example, medical devices. And they enforce, and penalty is very high. Like if there is a prohibited practices, then up to 35 million or 7% of global AUM turnover penalty. Other violation is up to 50 million euro or 3% of global turnover. If there is a misleading information, so up to 7.5 million euro or 1% of global turnover, they have to provide penalty. Then Singapore Smart Nation Initiative is also one of the thing, and it started in 2014. In 2024 October, they initiated with Smart Mission 2.0, which is basically built on trust, growth, and community. And they have started many things to that. One is SyncPass, which is a secure national digital identity system used by over 5 million people to access 2,700 plus government and private sector services. Smart Nation Sensor Platform, known as a SNSP. It is an island-wide network of sensors, including more than 1 lakh plus smart lampposts, which collect data for urban planning, traffic management, and incident response. Life SG is a one-stop mobile app which provide access over 100 government services tailored to major life milestone like birth registration, job seeking, and Go Business is a centralized platform for business to apply for license and grants. So this is the Singapore. Then India is also making progress in that by using Digital India and Society 5.0. So for that, we formalize Indo-Japan Next Generation Digital Partnership, which aim at leveraging digital public infrastructure by shared vision, human-centric transformation. And we know that Digital India, so Aadhaar, UPI, DigiLocker, these all are the some of the, we can say, achievement of Digital India. Society 5.0 is the Japan's conceptual framework that adopt by integrate physical and virtual worlds through AI and IoT. Then again, collaboration may be happen that like memorization of cooperation on AI-ready domains, which include digital public infrastructure for India. While Japan is integrating UPI, AI and semiconductors. So India-Japan AI initiative in 2025 focus on joint research in large language model and building resilient semiconductor supply chain. Next generation mobility is a framework to create AI-based maintenance for high-speed rail. And sustainable agriculture. So using Society 5.0, big data analysis and India scale to implement smart agriculture. And there are some strategic goals as well also. But these are the main thing that in reading framework. Then if we look at the challenges, it's up to 5-year timeline. So the one major challenge is energy gap, because renewable energy can keep pace with this exponential AI data center growth. And as we know that Google also started their data center near Vizag or Vishakhapatnam. And skill gap. So do have workforce initiated in ethical AI, green tech, and digital inclusion. So as the previous session, Dr. Kothari rightly said and explained what are the emerging areas or student can learn. And ethical gap, that algorithm bias, because they are mainly on data and what data already available. So machine learning or deep learning, all this model can have little bit bias and digital equity lagging in developing nations. So these are the challenges, how we can overcome. So this is the just a suggestive roadmap. It's not exactly that, but there is a, you can do that from 2025 to 26. Global standardization of green AI metric can be utilized for energy and carbon per inference. In the year 2026 and 27, Universal AI Safety Protocol, International Governance Framework can be rectified. 2027 to 28, 50% of AI system can use green computing standards, renewable power for 80% of data centers. 2028 to 30, universal internet access as human right and digital literacy can be go up to 85% globally. And up to by 2030, Society 5.0 framework operational in 50 plus nations. AI plus green tech energy reduce global emission by 10%. So the key takeaway, if I take that technology convergence is inevitable, AI plus green tech together should be used for sustainable development faster than only one. Trust is enabled, transparency, accountability, and human oversight build public confidence in innovation. Design should be human centric, so put dignity, diversity, and sustainability before innovation metrics. Global collaboration is essential, so harmonized governance enable cross border innovation and equity. And universities can make a very big role in that in research performance, efficiency, and social impact. So, what is our role in Society 5.0? So, design AI with green practice embedded from day one, prioritize transparency and human oversight in every system, advocate for inclusive, equitable adoption across all communities, build bridges across discipline, nations, and stakeholders, and publish not just on performance but on efficiency and social impact. So these are the all from my side. These four are the references and further reading. If you are interested, anyone can do that. And now you have a question or query.
Any questions? Okay. Thank you very much, sir, for enriching our knowledge about this topic. With moving ahead, now may I request our chairperson, Dr. Rishu Roy, madam, to give concluding remark for the session. Over to you, ma'am.
Am I audible, ma'am?
Yes, ma'am.
Okay. First of all, let me congratulate Dr. Preeti Khanna, Mr. Ankit Kothari, and Dr. Hiren Joshi for delivering such a amazing session wherein the layman can also understand the concepts they were trying to explain. As far as Dr. Preeti Khanna is concerned, she delivered an amazing session on deepfake. The session highlighted how deepfake technology uh, not only being innovative but also possesses serious threat related to legal, ethical, and social challenges. However, she concluded the session with a call that strong regulatory framework and responsible use of AI can act as an essential safeguard. Mr. Ankit Kothari's session was really very insightful, and was, I must say, that was much student oriented, wherein student can be benefited a lot. He also demonstrated the generative AI is transforming modern cloud data platforms. The session highlighted the need for strong security measures like encryption and access control to keep the data safe on cloud platforms. He also highlighted various challenges related to data security, building intelligent data platform, and he also focused that cost was a major factor in the governance. As far as the thing which was there for students were the kind of career they can pursue, like data engineer, cloud engineer, and the skills required to pursue this career was Python, cloud environment, data bricks, which can really make them industry ready. Dr. Hiren Joshi's session was really very helpful because he highlighted that technology must go beyond algorithms to focus on uh, human well-being and social good. In this context, he highlighted four dimensions. First was intelligence, sustainable, secure, and social. uh, he also emphasized how AI and green learning together can support sustainable and inclusive development, and the sweet spot he mentioned was federated learning. He concluded the overall session that future lies in people centric, sustainable, and trustworthy technological growth. So, this was all from my side. I must really thankful. I'm really thankful that you all spare your valuable time and enriched the students with knowledge and the practical things which will make them really industry ready. Over to you, Raksha.
Thank you very much, ma'am. Gratitude is attitude. With these words, I express my sincere thanks to Honorable VC Dr. Yogesh Goswami sir, Chairperson of our Avdharan 2025 Dr. Anand Rajawat sir, Convener of Avdharan 2025 Dr. Vijay Kumar Verma and Dr. Reena Gupta ma'am. I also extend my gratitude to Dr. Preeti Khanna ma'am, Professor at PDPM, Indian Institute of Information Technology, Design and Manufacturing, Jabalpur, for her thought-provoking words. I am also grateful to Mr. Ankit Kothari, Technical Architect, Cloud and Big Data Specialist, for sharing his knowledge with us. My sincere thanks to Dr. Hiren D. Joshi sir, Professor and Head, Department of Computer Science, Gujarat University, Ahmedabad. I also express my gratitude to our chairperson, Dr. Uttam Sharma sir, and Dr. Rishu Roy madam for spending their valuable time with us. At last, thanks to everyone who is associated in this conference and virtually present with us. Have a great day ahead. Thank you very much. Thanks once again.
Thank you all.
Thanks to everyone.
Thank you so much, ma'am, for
Thank
such
you.
an
Thank you, sir.
insightful session. Thank you, sir.
Thank you.
Thank you, Rishu, ma'am.